Hi folks, Matthew Lanigan here with BayWa RE. We're just going to give it another 2-3 minutes. People are still signing in and we'll be right back with you. Thanks so much. Hey folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer with BayWa. I head up the sales side of the business. Really thank you all for taking your time out of your busy day to be with us and learn a little bit about FLO chargers and Delta transformers. Just a couple of housekeeping notes. This will be recorded. We will share it during our December newsletter, so please keep that in mind. If you have questions, you can just enter them into the bottom right corner. We'll do our best to answer them as we go. If not, we'll have a bit of time at the end to catch up. Just once again, really appreciate you all being with us. Continuing education is a big part of the DNA of BayWa for our staff, and we love to be able to extend that to our customers as well. So without further ado, I would like to introduce from our friends with DAD Sales, the sales agents for FLO and Delta, Ben Wells, Application and Product Solutions, and Amy Holman, guys. Can't hear you, Ben.
All right, I thought I clicked the button, guys. Sorry about that. So thanks for having us, everybody. That was a great introduction. It's been a pleasure working with BayWa. And so because we are tight on time, I'm going to cut over to Amy. We're going to do a quick chat on FLO. I'm going to have a quick chat on Delta. It's probably not as thorough as I was like, but for some of you that might be great. But you're likely to have a lot of questions, and if we can't cover them in this session, then we're always available to answer them at any given time. So I'll pass that over to Amy. Thank you.
All right. Good day, everyone. So I'm going to be talking about FLO EV chargers today. Hopefully everyone can see my screen. Ben, can you just give me the okay on this one?
We can see.
Good. Yeah, you bet.
Okay. Perfect. Okay. Like I said, if any questions, just give me a call or just raise your hand or put it in the chat box, like Matt said. Yeah, here we go. All right. So FLO is one of the largest Canadian electrical vehicle car chargers in Canada right now. So we are also part of the Add Energy Group, a North American leading in charging solutions. And like our whole goal with FLO is to provide the best possible solution for the customer, the end user, and the easiest application for you guys as the contractors. They offer both smart home solutions for single families and multi-family units. And then we also are able to do turnkey solutions for property managers, owners, business owners, and you guys, the contractors as well, for installation purposes. we also we have a few different options, different solutions. Like I mentioned, we've got commercial units, we've got residential units, we've got the largest networking capabilities across Canada. As you can see, we've got over 100,000 members. We've got up to 100,000 sessions per month. So any questions, just feel free to reach us. Again, as we're the largest operated by AdEnergy, the Canadian leader in smart charging solutions. This is just to give you guys like a brief overview of kind of like what we see. The growth, as you can see, with electrical vehicle car chargers is only ever going to increase over the next 20 years, with forecasted up to 48% growth. Some of the other key points that we can take a look at here is we've got there's purchase incentives for the end user, as well as tax write-offs. As you can see here, we've got NRCan funding, and this is the number that we've got. We've got 130 million in the last 5 years forecast, or up to the next 3 years, with 2 years already added into this. We also provide, and we can take a look at different funding, working with Clean BC. Plus is the pricing of supply and things this year. It's just ever going to get better. We've got a few different this is a breakdown of the previous slide. So customers, basically, when we're looking at this, they want to look at what time savings you have and where you're going to most utilize it. We'll get into some of the breakdowns of the different products that we have available later on in the presentation, but based on the application. So on the go is going to be like your malls or gas stations, and 18% of the EV charger drivers are going to be looking at this when they're out and about doing their errands, going grocery shopping, stuff like that. When they're at work, it depends on the application, whether or not whether it's a charger at their shop or just down the street, stuff like that. So 19% of their time is going to be spent at work charging, and then 63% is at home. So what is the EV supply equipment, the EV SE, and the most important factors to do with this? So it's a two-way communication between the car and the charger. And it prevents a lot of issues as you're dealing with electricity. So it can detect hardware faults, any sort of disconnection, or if there's issues, if there's damages along any of the lines, it can prevent fire. You've got electrical shorts. It prevents too much flow of electricity. There's different ratings within the whole setup. And now we're going to get into some more of the the technical stuff. So your basic level 1 chargers are going to run on just your standard 520R plug. So there's different levels of our equipment. Level 2 charging stations come with this SAE unit. Tesla also provides this connector comes standard. It's type 2, whereas our fast DC also comes with 2 different versions. Types of charging speeds. This kind of follows same with the different types of adapters on the connectors. Your level 1 is going to be 120 volt. This is going to be your basic residential model. You can reach up to about 5 to 10 kilometers in an hour charge. So depending on what you're doing or where the application is for this, your charge speed increasingly gets better as you move through the different models. Level 2 charging stations, we've got, this one runs on a 240 volt or a 3-phase 120 208 volt. Again, your charging speed increases. For that 1 hour charge time frame, you can go up to 100 kilometer distance in a recharge. And then moving on to the level 3, you've got 480 volts, 277 volts, and then your distance per that 1 hour charge time frame is, you can go upwards of 300 kilometers. Now we're going to get into selecting a charger, and this is where we really get our hands involved in the application and figuring out what exactly the application requires. So we want to look at what your connection type is for all compatible with all EV chargers in North American market. Your charging speed. So this comes into on the previous slide where I was saying the level 1 for more of a residential application. Then you've got your level 2 and your level 3. So your charging speed. So what is the customer after? What is your application? Is it a business? Is it on the street? Is it at your house? This is where we take a look at what our options are. The level 2 operates at a 208, 240 volts. So it depends on the amperage of the charger and the car's acceptance in kilowatts. The smart features and the utilities. So it's got remote control option. This feature is useful for chargers for indoor or installed in outdoors because the car can connect to it anywhere. Data monitoring, we also offer that. So it kind of tells you your habits. It tells you, okay, you got home at 11 p.m. as compared to 9 p.m., stuff like that. Limiting output during certain hours of the day. So on peak hours, first thing in the morning when everybody's, showering, brushing their teeth, getting ready, cooking breakfast, stuff like that. Sharing power between one or more car chargers. We do have some options for multiple cables and power sharing. Location of the installation. Indoor versus outdoor is the first question. And most of our units are rated from minus 30 to 50 degrees up to 50 degrees Celsius. As well, Alberta, it's great. We love our rain and snow and all the ice right now. It plays into a factor in this Canadian market. And we have the capability to go down to minus 40. So depending on whether it's outdoor or indoor, we can play into that. Cable length, it depends. Again, this is where it's very application specific. Do you need 12 foot or do you need 25 foot? What's the park? Where can the vehicles park as compared to the unit itself? The factor of with the 25-foot cable, you can park your car forward or backwards. So the parking situation is a little bit more adaptable. Locking system. So we have NEMA 6-50P or NEMA 14-50 plug that we can offer if you are requiring the locking mechanism to prevent theft. Warranties. Most stations come with warranty covering the whole station for 3 years. And then we do have the option of the 5-year on the case and 3 years on the cable and connector. This gives you kind of a really good breakdown of their different units that cover off the different application locations. The residential, multi-residential is that level 2 charger. Like I said, in a few slides, we're going to get into the product specific, but we've got our level 2 charging station for Resi. We can go up to our level 2 charging station over here, which is the Core Plus. And then our level 3 charging station, which would be good for public scenarios, malls, gas stations. We do have a level 2 station over here that works really well in our curbside situation. So again, this would play into the 25-foot cable if this is the kind of the application that you're looking at. This is just a flow that you can see of the construction, project stage, the power, future proofing, installation and network management and maintenance. So we get involved in all of these avenues to assist, especially the project stage, to ensure that we've got the correct unit for what the application is. All right. And this is the fun part. This is talking about the product specifically. So these are our level 2 charging stations and then our smart DC. So this is where it kind of goes back to the 2 different ports that I showed this slide. So this is our level 2. So this is our most common adapter. And then the the Smart DC has the greater charger. Our G5 is our one of our most common residential units. This guy has it's a 6.2 to 2.7 kilowatt charging option. The wall mounted. This is one of the 3-year warranty units. It's quick, easy installation for the indoors and outdoors as well. Again, it comes down to like that temperature rating, so -40 up to 50 degrees, lasts over 10 years. Waterproof NEMA 4 aluminum casing, carbon finish with high resistance coating. This guy is voltage is 208 volt to 240 volt, 60 hertz, and it comes with the level 2 connector. The X5 is again another level 2 charging station, 3-year warranty. This has the capabilities with the components up to 10 years. So this guy again is temperature rated. This guy comes with has the possibility to do our networking capability. So this guy is more of a commercial grade. Again, it's got the NEMA 4X rating, aluminum housing, a different color for the aesthetically pleasing. And we've got our network, like I said, that you can monitor from your phone, whereas our G5 does not have the network capability. And that guy is across Canada. All of our data is stored in-house in Canada within its borders, and you can see once you use the networking capabilities, you can see any charger across the country as long as it is open to the public. For this guy, it's really good used for residential applications in your house. And then again, it's the same as the G5, so the one previous. The Core Plus. So this guy has the full network capability. The Core Plus is a super great unit because it has the RFID access. So really,
Amy, sorry to interrupt. We have a question here. Is the network feature able to program charge rates, i.e. may want to charge faster or slower based on time of day?
Maybe I'll step in there and give you a quick answer. So the X5 you just saw there is like, as Amy said, your network, we have networking features on it, but the primary difference between that and what we would call more of a commercial unit is that the X5 itself uses a little PLC that plugs into the wall. And so that would be much more in line with what you're used to seeing with hubs and just like Wemo or Eaton wiring devices or something like that. Maybe Hue is a good example. It'll give a homeowner an idea of what's going on with the charging session, but it really isn't aimed at going beyond those 4 walls so it won't have any payment processing, but the Core Plus and every unit Amy's about to go over is going to have full payment services, and you're going to the owner will set an account and then they can set their rates. So they can set whatever they want to charge, either per hour, per time, per hour, per session, and they have a graduated rate program as well. So you can start off at a low rate and then say, 2 or 3 hours, it can bump right up, and then they can move that over, get them moved on and get the station used by somebody else. So there's quite a few options in respect to that, but you're going to normally pay through your phone, either Apple Pay, Google Pay, or tap through the RFID card, and you can supply cards. So it's about authenticating to the station.
Does that answer the question?
Yeah, that's great. Thank you.
Perfect. So yeah, so as Ben was saying, is like the G5, the X5 are more rated for like the residential at home, whereas all these commercial products that I'm going to get into here shortly are more of the fun, where you can control and change the charge factor. So this kind of just shows you our cable management system, so that 25-foot cord isn't dragging on the ground. Again, we've got that level 2 connector on the Core Plus unit, RFID reader. So this is again where it plays into like that networking on the app as well as on the machines itself that can take credit card, Apple Pay, Google Pay, stuff like that. So this kind of shows you some different application mounting and like depending on what your application is, if you just need like the pedestal mount, wall mount, if you want the dual side by side, and this is where I mentioned previously the power sharing can play into it, as well as you've got the wall mounted, and these 3 units have the cable management system. Power sharing, so this kind of gets into where I was just speaking. So here we can, if you're using just one vehicle, then obviously that vehicle is gonna use all that power if the other units are not being used. Whereas if you've got two vehicles plugged in, Mark comes in, starts charging at 7.2, and then Susan comes in, and so then it's split equally between the 2 units. And then once Mark's fully charged, then Susan will get the full. So it just kind of process of elimination, and based on the 7.2, is this still the constant between all 3 units of sharing. Power limiting and daisy chaining. Ben, I might get you to briefly just kind of touch on.
Sure. So these are power management technologies, both power sharing and power limiting. And the aim in these is to mitigate the overall loading of the panel as to keep the install costs low. And the code, the new adoption of the code, section 86, I believe it is, allows us to use energy management to mitigate the table 8 loading. And so that's a nice advantage because otherwise, in many cases, these aren't realistic to install in any volume. So both power sharing and power limiting do a good job of mitigating that. And the power limiting, for those of you that are out east or in jurisdictions where you're charged on pool pricing or where you have varying rates throughout the day based on loading and demand, you can set your charging station to basically draw power only between certain hours. And that's a really nice feature for a variety of reasons, because of course, if we're say using that feature to only charge it during the night, for example, then there's a less likelihood of loads being on in the home or in the commercial building. So there's some opportunities to kind of leverage this and respect the code. But yeah, that in short, that's how those technologies work.
Thanks, Ben. We're going to move into the Smart 2 product. So this is, again, moving up in the level of product from the residential, the G5, X5, moving into the Core Plus, and now we're into the Smart 2. So again, we're just moving through all the way up to like the level 3. So in this unit, the Smart 2, the BSR, so this guy, again, so it kind of, this description just kind of breaks down. You still got the RFID reader. So this unit has that locking mechanism. So if you are in a public space and you want to ensure that your connectors are lockable, we've got that option here. We've got the antennae up here that has more capabilities within that network. We've also got, again, the LED screens, the OLED that are rated for our Canadian winters. We've got, so this guy again, 3R, fully lockable. And this guy requires 2 40-amp pole breakers for the application. This sheet just shows kind of similar to our Core Plus and the G5, X5 units, that just different mounting options, kind of like the aesthetic, the look. We've got the wall mount. We can do dual wall mount. We've got these on pedestals, or we can even pole mount. And then the cord wraps nicely around there, and then you've got your screen up top here. And then now moving into the level 3, the fast charger. So this is our highest level of chargers, the Smart DC. So this guy, we've already got over 200 units across Canada. Again, NEMA 3R. we've got, so this guy, the maximum output is 50 kilowatts to four 12.5 kilowatt modules. So it can do up to that 250 kilometer range per hour. If you guys remember.
Just realized your slide's out of date, Amy. I'll help you out a bit with this. Okay, so in short, we've talked, Amy's done a good job of kind of going over some of the charging speeds and rates. So I just wanted to kind of step in because this is where, you know, the smoke and mirrors really starts in EV car charging. In one of the slides that we talked a little bit about the input rate of the vehicle. And so we break this down into two different buckets, right? You have your AC charging, okay? In an AC charging scenario, the charge controller is going to be in the vehicle. So that the car itself is going to determine how much input charge it can take. And it'll still do that on the DC side, but it's basically more just providing information back to the charge controller, in this case, the smart DC model. So DC, AC different. They obviously are both being fed by AC, but the DC systems do a really fast charge direct to the battery, and there's a bit of a difference there. So on the AC side, we can go all the way up to 19.2 kilowatts, which will provide, you know, a pretty meaningful charge for most vehicles. That's 80 amps. So we can go all the way up to that in AC. But when we move over to the DC side, FLO starts at 50 kilowatts, and we also have a 100 kilowatt unit. And we can, there's Tesla, for example, goes all the way up to 350 kilowatts. So when we say provides up to 250 kilometers, 300 kilometers, 350 kilometers, we're making the assumption that that car can take the entire input charge. And in many cases, that's not true. Right now, the bulk of the vehicles on the road today work really well with a 100 kilowatt charger. They're going to get a good, they're going to almost maximize that unit. But situations where you're seeing 150, 200, 350 kilowatts, that's where you're going to want to have a lot of caution for two reasons. One is the cost, obviously. But the other one is that we want to kind of steer away people from making a bad choice. So, for example, these are very hard on batteries. They said they're expensive, and if you beef it up to a 350 kilowatt unit, then you also have to have the surface to do it. And if your car can't take the charge, so use case is very important in selecting an EV charger. So when we get into these DC fast chargers, I really want to throw a little caution into that. These are 480 volts too. Which, you know, I understand it would be ideal to do it at 600, but one of the things you guys in the solar side understand well is the inverter technology, right? So inverter technology often is at 480 volts, which is frustrating, but it's often a cost position. So if the bulk of the, you know, US market's going to use 480, then the cost position for a 480 volt inverter is lower, and that's really the same aim here with the DC fast charger, because the DC fast charger is basically like stuffing 4 inverters in a box, which I don't think you're allowed to stick one in a box. So to put that into perspective for you, so you want to be very cautious. These require maintenance programs. Well applied, they're phenomenal, and that's what you're seeing in the gas stations, at Canadian Tires, you know, at utilities, you're using them. And so in the right application, this is exactly the right product to use. But you just need to keep in mind that, you know, once you leave the AC world, you really need to understand your use case, because it's not as universal an application. Whereas in the AC side, all North American vehicles, period, full stop, are going to use the J1772 connector, which is the level 2 one. And then, of course, as Amy had mentioned, Tesla has a proprietary connector, but they're still using the same standard, or the same communication and protocol standards set forth by the Society of Automotive Engineers. Okay, so that's an important thing to understand, because that makes the landscape for EV charging in North America truly universal. Sorry about that, Amy.
And guys, I just wanted to add to it, you know, for customers out there, if you do have a request for these, it's not, you know, simply just call us and we'll give you a quote. It's a consultation. We want to consultate you folks on it. So please just reach out to your rep, and we'll work with DAD and FLO to get you something that truly is tailored to your needs.
And that's exactly right, Matt. This very much plays into how we get involved early on in the quoting process. We look at your application, we find out what you want. As the business owner, does the business owner want this for private use? Do they want it for public use? Like we start right at the boot on the ground, and we work it through, and we find the best charger for the application. All right. And
We do have one question here. Does
Yep.
the unit with the Zigbee still require Ethernet connection?
An excellent question. So let me just break into the communications really quickly. So we talked really quickly about the PLC for the residential side. So that's getting line voltage communication back to the chargers through the bus. In the case of our commercial units, they use a remote gateway. Okay, so the remote's important because you don't get to choose where your parking stall is, but you do get to choose where you put your gateway. So that's why we do that. It is a remote head. It's a remote unit. It uses 3G out of the box. So when we quote you guys, we're quoting you 2 years of networking management and monitoring. And of course, that includes the gateway rental and it includes the networking fees. So all that's included. And we do the commissioning at our plant. And that remote gateway means that we can address the charging heads to the gateway per the owner's instructions, so that when it arrives out in the field, what you're looking to do is install that gateway. You can apply 120, it's just a 120 volt plug-in gateway, okay? But you can put 208 to it using a power supply. So you really are flexible. 208, no neutral, of course. That's an option for you guys. So now the other thing is to understand about the networking is that we choose 3G as a preference because it allows us to fully commission at our plant. But you could put Cat 5 to it or Cat 6 or whatever category cable you want to apply to it. That's not a problem. We just need to know that at time of commissioning, because what we'll do is we'll swap the gateway to ensure that we're not selecting a gateway that can't be hardwired, and then we make sure that it's as easy for the installer as possible. But they still are going to have to work with that firewall if it exists on the owner's side. So our preference is always to go 3G remote. The only exception to that would be that BSR that Amy showed with that antenna on top. That's a city curbside unit. And because in the city curbside applications, you don't have the luxury typically of a remote gateway, so we put it into the system. So we can do that with all of our BSR product. But when we're looking at most installs, remote gateway is a really good solution. And then what happens on the other side of that gateway is we use a Zigbee mesh, which really does a good job at a really reliable connection on the owner's side. And then of course using LTE, 3G or whatever to get out. Not a lot of data goes out the door, so it's not like we need a lot of what we need is a relatively stable connection. So we suggest you take your cell phone and check for bars where you're planning on installing that 3G unit. And then you just want to keep in mind that Zigbee operates on a line of sight about 150 meters. So if you've got that space, line of sight, great. If you're going to go through a wall, I want you to be a little more careful because it does cut the signal down. But anecdotally speaking, I've seen many installs where we're on the other side of a concrete wall, admittedly close to the source, but you know, it does punch through. It's just every site is different, so we prefer to have that line of sight.
Great, thank you.
all right. The last touch a bit that I wanted to go over about the FLO is kind of diving into that network experience that both Ben and I have kind of brought up a few times. So the thing with the networking, it offers Canada-wide coverage from all different units. If you choose to go with the public version, then you can see all kinds of public use chargers across Canada. And like us, I haven't jumped on the EV bandwagon myself for a car, so my car's still gas. But for me, it's like I look and, you know, okay, where can I get gas on a road trip? You know, our EV drivers are looking for where can we charge. So the maps offer that. They also, you know, you're able to see real-time charging and billing data based on those different usages. You can also find out what unit is where. So if you're using the fast DC or the smart DC, sorry, at the shopping mall, and then you want to go and, you know, go home, you've got the different units there. We've got the payment card industry compliance system. I might get Ben you to touch on that system.
Sure. Yeah, actually, it's a really important point you're bringing up. So the PCI compliance, so that's just like ISO of payment processing, which is really what it basically means is that we're protecting your data. It's like a protocol. So Accountants are much better at explaining how that all works, but what you need to understand is that payment compliance systems are really important, especially for government organizations. And when it comes to payment card processing, FLO charges in Canadian dollars and applies GST. So these are things that our owners are very concerned with. A lot of the municipalities are focused on working with FLO for this particular reason. And, you know, like BlackBerry has really been an effective company because it's, you know, for the Canadian government, because they store their data in Canada. So does FLO. All of our data is stored in a secure Azure server in Toronto, is where we keep our data. So that does mean that all appropriate legislation is going to be related to, they're going to want to do it out of Quebec, but it's at least in Canada. So we have that kind of going for us in that respect, because alternatively, you know, if for example, Home Depot gets hacked, we got to go take them to court in California. And, you know, that's maybe not convenient for us guys in Canada. So there's a lot of that under the hood stuff. And the other thing that's really worth keeping in mind is it's bilingual ability to service the customer through both AMA and by FLO through the owners. So for those of you that have customers that are using both official languages or or French, for example, then they can take advantage of that. But these are really key and important things to understand, because this is how you can feel God. You know, it's like your cell phone. I got my cell before the CRTC fixed it. We would have to go, and you didn't like TELUS, you didn't like Rogers, you didn't like Bell. You had nowhere to go because your phone was locked in. And while that's not the case with car charges, you can take them and they roam to other networks. It is important to understand that, you know, it's not an easy thing to move over, and it's not, you know, these are the things that are nuanced that, you know, you don't see on the spec sheet. So that's why that's really important. We're getting a little short for time here, guys, so I'm just going to wrap this up. Amy, can you just flip to the next slide? Because otherwise we're never going to fly. No, next one, sorry, Amy. Yeah, perfect. I want to talk a little bit about this before we move on. Maybe we'll take a couple questions and then, you know, discuss transformers. But the global management service is that gateway service that I mentioned earlier. This is kind of what you get. So you get access to the portal, you can set rates, you can do your billing and all that. You're going to get the FLO network to monitor the station. If there's any downtime, they're going to, of course, let the owner know, or whoever they have written down as their maintenance electrician. And it's basically kind of, you know, the value beyond the car charger itself. For a lot of guys, this little feature here is key because, as Amy had mentioned earlier, if you're charging 60% of the time in your residence, then you have 20 or 40% of the time you're out in the wild, okay? So at least 20% of that time, you're going to a place of commerce. So being located on the map has tremendous value. It's so much value, in fact, that a lot of guys are taking the purchase to make car charging, like especially in like developers, for example, or people that have small businesses where they serve sandwiches and donuts and stuff. They're finding tremendous value in driving customers to their business, because this range anxiety, you know, I don't have enough power. I can always go fill up my gasoline vehicle in like less than 5 minutes, but if it's going to take me hours to charge an electric vehicle, then that's the challenge. So this ability to drive into this, to take advantage of that anxiety, if you will, to get people to come to your business is a really great marketing advantage. So in applications like that, I recommend that they have a long, hard look at their marketing budgets, which are quite often greater than the capital and installation cost of a level 2 charger, to consider shifting some money away from marketing and putting it into this, because you're still going to receive that marketing value. The sooner you do that, the more value you're going to get. And so that's really important to understand. The only other thing I wanted to mention, we talked a little bit about charging speeds in the DC side. I just want to circle back a little bit on the AC side and help you guys really understand how EV charging works. Currently, the input speed for most electric vehicles today is 7.2 kilowatts, as in they can't take more. Okay, so guys that come to you and say, I want more and more and more, it's just harder and harder to install and more money to install. So when we look at the speed of an electric vehicle charging system, we really want to match it to that inlet speed. Now, admittedly, in the last little bit, we've seen a big shift towards 11.2 kilowatts. So Ford and Tesla and a lot of those guys are living in that speed range, okay? So you could take a Core Max, for example, at 19.2 kilowatts, and you can throttle it back. You can do that with Tesla, you can do that in general terms. you really want to dial it in for the connector you're attaching it to. So that's really important. The only other thing I wanted to say is you're going to get that level 1 charger with the car. So we don't offer one. Okay, level 1 charging is real if, you know, because the average commuters in Canada travels about 15,000 kilometers per year. And that means that you're looking at about 50 kilometers per day in the daily commute. And generally speaking, they charge every day or every other day. So on a level 2 charger at 7.2 kilowatts, you're looking at an hour and a half to 3 hours of charging per day. So if you think about a couple, husband and wife, they both have a Tesla 3 and they want to charge, well, really, realistically speaking, you might want 2 heads, but you could theoretically go with a very low 7.2 kilowatts for both vehicles. So you could do as a GX5, for example, and split the power. And that's an important understanding because a lot of people will look at 650 kilometers and they'll say that's 11 hours on a level 2 charger. And that's just not good enough. But in fact, it is good enough because rarely, unless the use case suggests you're going to be driving about 600 kilometers per day, that is not realistic. As long as you can recover the charge in that scenario, in an overnight scenario, you're probably okay. So more is not better. It just means harder to install and more money. So if you're looking to future-proof, we would want to talk to you about that so you understand ways that that can be mitigated, say through power sharing and some future-proofing options, including using something like a 19.2 kilowatt charger. Now, we didn't talk money. I'm going to do that really quickly for you guys. Level 1 chargers come with cars, we won't talk about it. Level 2 chargers are going to range anywhere between about $1,000 to let's go all the way up to our Smart 2 BSR. Like you could see those going up to $5,000 and $6,000 per head. So, but the good news in that is that our Core Plus and our Core Max, about $3,500 for the Core Plus and about $4,100 for the Core Max. And at 19 kilowatts, that's a really great deal. So there is a real easy opportunity here to go to that larger unit and then downsize. It's a great way to go. And when you think about 50 kilowatts, 50 kilowatt unit would be about $40,000 or so, depending on how you dress it up. And a 100 kilowatt unit will be about 80. So you can do a lot of level 2 stations. So understanding the use case will kind of drive those decisions. And we're very happy to like break down every individual application we deal with today. Okay, so finally, guys, what makes FLO different is, if I'm being fair, we're really high quality products. So that's cast aluminum, that is rated for our weather. We don't have full color screens. That is intentional, entirely intentional, guys, because in our Canadian winters, the delay that is placed on an LCD screen in the cold is for a lot of people untenable. And while they'll work, I promise they'll work, you will see that delay. And all you need to do is look at Canadian parking equipment to understand what types of screens they're using. So again, that is an intentional design consideration. It is not a competitive disadvantage because there are some really pretty color LCD screens on the market, and you can do that. You can go and do that, but you need to make sure that the display you're using, the liquid crystal display you're using, is not only rated for the temperature, but more importantly, rated for that lag. And those tend to be more expensive than a car charger in general, you know, so they really shouldn't be used in our climates, and plastic is probably not appropriate for a duty cycle. So in some cases, we feel we're overbuilt, especially when you're putting it in a nice warm garage. So I will accept the fact that in those applications, we might be overdressed a bit, but in the rest of the situation, especially commercial, we're very, very strong, and we're very, very good at that particular market. So we enjoy a lot of success with the municipalities and the big players. So you know, that's really helped us understand the Canadian market quite a bit. Any questions, guys? Thank you very much, Amy. That was great.
Thanks, Ben.
Yeah, there's a couple here. What about monthly software as a service fees?
Great question. I should have covered that. I apologize for not covering that when we were discussing the global management system. So that global management system, guys, as I indicated, covers 2 years up front. So we do that because of building handover. We do that because we don't want owners feeling nickeled and dimed. And initially, they're likely not to get the full usage / ROI of their system. We don't want them to feel bad. So we include that for 2 years capital cost. Now, after that, it's $150 per year per head. Okay, $150 per year per head. The X5 has no networking fees at all. Okay, that's just, you know, like you don't pay anything for that. But when it comes to accessing those global management services, including payments, that's $150 per head. So that's not a lot different than Costco. as we use our Costco membership throughout the year, then, you know, what comes onto our account generally pays for our membership every year. And if you're like me, I think I get a pretty decent check. So, which is the idea. So before I get asked, because it just came to mind, I get asked a lot, how much does a cost to charge a car? So an electric vehicle, guys, it's about 20% of the cost, depending on your jurisdiction. In Alberta, we pay some of the lowest energy rates in the country, and the delivered price of electricity in Alberta is 15 to 20 cents. Having said that, I don't really need to get into that very much, because you guys in your field are experts at this, understanding the cost of electricity, of course, because you're doing on the solar side, that's a big part of it. So understanding that's key. So for you, 7.2 kilowatts, you're looking, depending on how the numbers you use, you're living at about $1, you know, $1 per hour or so. Okay, so that's the key. I need to understand that, because guys want to know what their ROIs are. So I generally say, look at your ROI on the equipment for 5 years and look at, which, you know, isn't bad, right? Because I'm talking to a solar audience here, so that's not terrible. So about 5 years, and then, you know, just with general use of the station, about 3 hours per day. Okay. So, and then I'm kind of seeing all across the country different rates. Quebec and BC are quite a bit more mature than the rest of the country. Ontario, Alberta, the East, and of course Central Canada, about $1 to $2.50, $3 per charge. Of course, BC and Quebec get more because they have higher demand. And on the DC fast charger, of course, you can do the math as well as I can, but you know, when you're looking at 50 kilowatts, 100 kilowatts, depending on its draw, these are maximum draws. So you're not likely to pay that, but it's just so you understand conservatively the maximum. That would be $20 to $25 an hour that people are paying for those charging sessions. So, you know, you're actually going to get a much significant better ROI on a 50 kilowatt DC unit than a 100 kilowatt DC unit for that particular reason. Now, just so you understand, again, depending on your jurisdiction, you need to look at the regulator in that province to understand whether or not you're able to resell electricity and what the legislation looks like. In many parts of the country, you need to be registered with the retailer, or it depends, right? Everybody's a little different, but you need to be allowed to resell power. So FLO has a metered system, as in we've been inspected per CSA to be a meter, so we have a very accurate system, and it'll tell you your usage in kilowatts, obviously. But here's where it gets a little dicey by law, is that in many places we're not allowed to sell per kilowatts. So keep that in mind. Some guys don't know that, and they're selling into Canada and they don't understand the consequences of that. So we charge per hour, per session, and that's kind of how we skirt it. So the relationship between electricity rates and what you charge per hour is important. And then you can keep modifying and changing how much you're charging based on what the landed costs really are. And you can do that. You can pull the delivered electricity rates on your bill by simply taking your kilowatt usages and then dividing it out. Now, I understand that's a little more complicated for people under pool. And so you might consider shifting the rates per out the day, but that I'd leave to you, and we're more than happy to consult with you on that. Okay, so that's it. Do we have any other questions, guys?
There's a few, but I think in the interest of time, we can round back with those. So we'll follow up with the ones we haven't gotten so we can get to our transformers here.
That sounds good. And I am going to do my best here. I'm going to share my screen. So bear with
Ben,
me.
I think I sent it to you.
You sent it to me? I have the one I'm using right here. What do we have here? Do you see my screen at all?
Yep.
Which one? My messy desktop?
Yeah.
Okay, I'll just change this here. Sorry about my messy desktop, guys. Here we go. Okay, so I'm just going to show really quickly here a little bit on Delta transformers. Okay, so really quickly, guys, Delta transformers, they're made in Canada. It's a really highly respected line throughout the country. We have very strong spec position. We are owned by Holman Transformers, so we maintain the same quality levels as Holman does. We are totally independent companies, and sometimes it feels like that couldn't be more true, actually, as I find myself competing with them. But they make a great product, and so do we. Slightly different mousetraps. We use EVI. We're famous for EVI. EVI is epoxy vacuum impregnation, and so when you have a core like this, the biggest risk to damage of a core is the shorting between windings. And so we all manage that by coating our transformer cores. And in the case of Delta, we do an epoxy vacuum impregnation. And so the nice thing about epoxy is it's a little more flexible. So as we go through heating and cooling cycles, that's a really important thing to understand, that's kind of where these things break down over time. They crack, you know, things like varnish are the worst you can possibly use, right? So you'll see that in the very inexpensive, like what I call like CRU, commercial rental unit transformers. Basically like good for a panel board or two. You know, you don't typically want to use that in any major commercial building. And that's just in general terms. But when we're discussing transformers and solar, things change quite a bit. And the reason for that is that it's all in the loading, guys. So a typical transformer, an engineer will load that at about 80%, and that's typically at the full building load. Whereas with PV transformer, you know, we're loading those typically to about 100%, as much as I should say, based on the design load. Now that's actually one good point. You can simply oversize your transformer. That has repercussions in respect to fault currents and things like that. But you can do it, and the nice thing about doing that is, of course, you keep your transformer running cooler, and it of course keeps your efficiencies higher. So that's really what this is about, is that we don't want the transformer to be the bottleneck in your plant. I mean, I think that's a really important consideration, because we go to such great lengths to buy such amazing inverters. Inverter technology today is just beyond belief. I'm very impressed with it. I don't sell it. Kind of wish I did, to be honest, because it's pretty neat. But those inverters, of course, are very efficient. So why would we not want the transformer to be just as efficient? It seems silly to me that you go to all that trouble and then bottleneck it out. So, you know, this is really about that. It's about efficiency. But there's a couple technical reasons outside of that. We're going to get into those. You guys know this, right? YY connections. The other thing is, a lot of guys come to us with transformers flipped around for PV. So just really quickly on that note is you really want to have a transformer that is energized by the utility side, okay, not energized by the array. So that's really where we get the primary secondary flipped around, and that's important because it generates a lot of inrush and can create damage to the inverter specifically. They're very susceptible to that. Now, the nice thing is those inverters, as I said, are really high quality. They have MOVs, that's metal oxide varistors, or some version of thermal surge protection. And over time, they are sacrificial, so they get worn down. And if your plant lifespan is aimed at 25, 30 plus years, then, you know, this is a major problem, because at some point during that time, the MOV will fail. And eventually that plant will succumb to the transformer being pointed in the wrong direction. So the transformer isn't always wound up by the transformer should always be energized by the utility side. The exception to that, okay, would be when we do not have an inverter that is doing the work preventing the array from powering the transformer. So as in when utility power is lost, then of course the inverter is doing the work saying, hold on, I lost utility power. Just, you know, depending on the system, of course, using optimizers, you can shut it right down at the array, right? So if that's going on, then really you always want the transformer energized by the utility, okay? Very few examples today where that is not the case. So that's the first thing. The second thing is we want to make sure that we deal with these efficiencies. Okay, we discussed a little bit about the expansion and cycling, so on the EVI process. So that's really an EVI play. All transformers are going to fight through this expansion and cycling. They should be designed to do that, and the higher quality transformers are going to give you that advantage. I'd like to say that Delta makes the best transformer because of that EVI. A lot of engineers agree with me, but if I'm being totally fair, that would be what I would call a marginal improvement over some of our strong competitors. The other thing to keep in mind is the harmonics are pretty significant, as are any nonlinear loads. Now, this is changing very quickly. Again, the inverter guys are always impressing me. They just keep dealing with the problems that I struggle to with a transformer and other technologies. So hats off to them. You know, vandalism I don't see very much because these sites are very protected. But nonetheless, that would be a potential threat to any system that's on the ground, I suppose. Customer demands, efficiency being the number one. Let's just call that the key there. Okay, so I'm going to talk about circulating currents in a second here. Efficiency is my big one, so I'm just going to skip this slide. Okay, so this is the issue with transformers, okay, is that they generate heat. When NRCan's Natural Resources Canada, they're responsible for policing environmental catastrophes, and transformers largely are just that. We size a building at 80%, okay, load, and then we put a transformer in there. That's fine when the building's under load. When the building is not under load, we still have to energize that core. So that means at nighttime, when they're not using all that power, it's just like a giant heater in a room. So NRCan went ahead and said, you got to change that, guys. You can't be on no loads or low load transformers. You can't be losing all that heat. So they forced us to redesign transformers in total. Like, that's the crazy truth about what happened with 802. And it meant that no longer could we cut any corners. So what we have to do is do what's called a step lap. And you can see right in this transformer here that it's like a mitered out frame. Okay, that's so that the electrons follow the grain, and as they do, there's less resistance, therefore less heat. So that's an important understanding with 802, and that was aimed at low or no loss, or like no load losses. So when we don't have loads, they improved it up to 98% efficient. So that's true. They're 98% efficient in that environment, like when we're into low loading. Okay, so when we get into a transformer application, I'll just stick on the side for a second. When we get on a transformer application like that, where we're fully loading it or we're getting closer to the 100%, the NRCan transformer was never designed for that, okay? That was not the aim of that. So you might have a 98% efficient transformer, but not at those loads. And I should have a jump here a bit if I can find it, because we're not going to go through all these. I'm not going to do that to you. Okay, so this is a good little slide, okay, because showing a 75 kVA transformer in both copper, I think it's copper, yeah, it's all copper. Yeah, so it shows here the losses under no loads, okay? So under no loads, this is where the NRCan made it more efficient, okay? And the load losses, so when we're under load. And you'll see here how the efficiency changes as we get up to 100%, okay? And what this is showing you is a general purpose transformer pre-NRCan. This is what happened with NRCan. We made them better. That's good. And then with 18, so this is an NRCan standard, but we're using that NRCan standard to make what's called a PV transformer. Delta is not calling them bidirectional. I find that incredibly frustrating because it's just a marketing discussion. Hammond is a great manufacturer, as I mentioned. They are saying their transformers are bidirectional and they're putting them on the nameplates. If you have a request for us to put a nameplate with bidirectional on it, we will. And we are going to make that change in our marketing literature and probably make the change based on Hammond and what they're doing. A transformer by default is bidirectional. So there's no, it's not like a breaker or something like that where a bidirectional is a technical thing. This is a marketing thing. So by going ahead and saying that our transformer is bidirectional and the code is now, we all lobby the code groups. So you know all about that on the solar side. And when we do that, they take our recommendations, and the idea being, well, clarity is never bad, which I find slightly ironic. Anyway, needless to say, in the higher end here, they say a C80218, we're looking at that high efficiency difference, and it seems like a small amount when you look at like 96 to 97. We're only talking about a percent or so. But if we were to look at this in respect to money now, this is the cost to operate the transformer, okay? In this last column here. And so it's not a massive difference. We're talking about $700 in losses. So you tell me how important that is to your customer, because this is only a 75 kVA transformer, not a 225. So that's why it's really worth looking at. And the annual costs, you can mess with the numbers, and we have spreadsheets for this purpose. So if you want to like pump in your own numbers to understand the ramifications of doing so. Now, just so you understand the difference in cost between 802.12 and an 802.18 or a PV transformer is, maybe $1,000 or something, which is not insignificant. I'm not making light of that, but when you look at, saving $700 a year in losses, it only takes an ROI of 2 years or less to achieve, the difference, and then you at least know you have a high quality unit. The only other thing about PV transformers I want to talk about a bit here, the YY connection we discussed, that's pretty standard. You guys have been doing that forever. I want to show you cores and how they use core technology to manage some of the issues with that. Find the slide. Here it is. Okay, so in solar transformers, we love, you guys may not let us do this because you can still have the efficiency with a three-legged core. So that's important to understand. As much as I think you should do it, from a technical perspective, you don't need to do it. So think everything I said to you is valid on a three-legged core, okay? So there's still PV transformers, 3 legs. But adding a 4th leg is a really good idea. 5 is even better. And this is where the inverter kind of can, depending on the inverter, fail you a bit. Inverters are designed to look for phase loss, okay? So when you're connected to a disconnect, say from the utility direct, say to an inverter, you're gonna use a 600 volt inverter, say to feed directly to a service, or maybe you're using a 277 or 208 volt inverter, you're gonna put it right to a service, you're not gonna use a transformer, which by the way is a great choice. I'm sure you'll all agree. If we can avoid the transformer, you avoid the bottleneck. That's a good thing. But when you do need a transformer, if you have phase loss, say on a disconnect, you lose a fuse or something, the inverter doesn't get a clear view of the loss. It'll see the secondary side of the transformer, and in a three-legged core, you get these like eddy currents that kind of fall back, even in a phase loss scenario. So say we lost, a third leg C. So the transformer doesn't care, frankly. It's still going to have A and B energized, and that means that the potential exists for you to induce voltage to the leg of the missing leg here. Okay, so let's say winding C or fuse C goes, we will still see voltage appear on the secondary of C. And that may not be a ton of voltage, but it will be enough voltage that the inverter will be confused, very confused, but it'll be confused at an unbalanced load. And this is what we're really worried about, is that scenario. And if you go and talk to your inverter manufacturers, they'll tell you the same thing. Is first, they'll tell you we're warranted for this. So you get a warranty, don't worry about it. And our stations are pretty robust, so we can handle some of this. They'll also tell you that occasionally it will see plant downtime as a result of this phenomenon. And you get a one extra leg will kind of give that return path. It means that we kind of trap those magnetic currents, or we channel them better, I guess is the way to look at that. So you're still going to see voltage even in a 4-legged core, but admittedly, you'll likely see significantly less. And I say likely because this is a magnetic force. There's more than 1 or 2 factors being played here. And then, of course, the 5th leg would give you the other side of that transformer for the same reason. And in a 5th-legged core, that phase loss is not an issue. So what will happen with a 5-legged core is for certain the inverter is going to see the phase loss and it'll shut down. So that's really a key thing to understand about the way that these transformers work in respect to phase loss. We do everything. We do copper, aluminum. We will work with OEMs as needed to help you integrate into gear and that sort of thing. And Delta will supply core only, so you can integrate it into a piece of switch gear or something like that. So what we're seeing on the farm side is the desire to do more of that sort of thing, because we can put it on a skid and drop it into a field and manage our labor position just a little bit better. I'm not really keen on getting into like every little detail, but what I will, because I think that everybody's application is different, everybody has a slightly different view of what's important to them. But in short, think efficiency number 1 when it comes to this. Think of the transformer like a bottleneck or a solution to a bottleneck, so look at that efficiency. And then just understand that I'm selling insurance entirely on the 4th and 5th leg. My belief is it's probably worthwhile given the cost to do so. But you start putting a 5-leg and you go for the high efficiency, it's not $1,000 anymore. It could be as much as double. So I got to be fair and say so. So it's really up to your threshold for risk, or the customer's risk threshold, to determine whether or not you want to see that 5th or 4th leg, or 4th or 5th leg on the transformer. But definitely, we want to point these things in the right direction, energized from the utility. We want to make sure we're getting a transformer that is highly efficient at full loading. And those are the key things that make a solar transformer different. So when you come, BayWa has a really good intake form for this. So that's kind of nice. And what it does really well is I'm going to throw myself on camera here for a sec. What it does really well, there I am, sorry guys, is that geez, what was I just got so confused with all the buttons in front of me. Oh yeah, the intake form. So the nice thing about the intake form is it's complete. So if you use that intake form and you try to fill it out as completely as possible, that's great. If you're having any questions with that, we can help you. And then when we start talking about power transformers, which I haven't been discussing, because really you're going to buy PV transformers. The power transformers are they're not really solar related, I guess. They're just more like a transformer, but we do those too, and we can assist you with that. And we can assist you in sizing if that's something you wanted to discuss with us. So we're really able to answer those questions and get into a more custom application for you. So that's it for me on the Delta side. Sorry if I ran a little long, it looks like I did, but I am ready to answer questions if you guys have any.
Thanks, Ben. There's a couple here. What is the upper KVA sizing limit for Delta?
It's a great question. So we build all our transformers custom. So, but we typically start shifting over to the power transformers after, 500 kVA. That'll depend a little bit on the material type. So I think when it comes to copper, we're quite a bit more limited than in, say, aluminum. Aluminum is more limited than copper because at some point you just get so big with the cores that, so copper tends to be able to go into those higher ones there. But like 500 kVA for a solar transformer, we can do bigger. So if you were to say do a power transformer, we would do it in a high efficiency power transformer. And really all that is just a higher kVA, and we tap it so that it's not, doesn't have all that inrush. Well, it'll have inrush, but it just won't have oversized inrush, I suppose. So we can dial these things in, and so it's a bit of a loose answer, but typically we don't sell over 300 kVA. And the reason for that primarily is the physical geographical location, okay? Is we've kind of moved away from the central combining gear. And so for that reason, we tend to see these things pushed out a little bit more. One rooftop to an X might have its own wireways. So for that reason, but yeah, to answer the question, in short, we can customize them to whatever, and because they're built custom anyway. It takes, so for us at Delta and Hammond as well, we build everything custom. Now we might have built it before, but it's custom because we still build to order. So.
Great. And one more, what are the lifespans of transformers, and is there an expected efficiency degradation rate year? Also, do you see new 18 transformers upgraded from energy efficiency standpoint alone?
Good questions. Yeah, those are good questions. So warranty is like 1 year, so like a lot of things, but the lifespan, so we use that EVI process in oil and gas applications quite a bit. Very similar idea. It's called our EnviroGuard transformer. They're meant to sustain the worst of what's out there, caustic, nasty chemicals, and it sustains them really well. The thermal properties of it's really strong. So lifespan, can I say indefinite? I guess it depends on the application. So if well applied and you have the right type of transformer, as in you have an outdoor transformer for an outdoor application and you're applying them correctly, you should see them last almost indefinitely. I don't see any reason to say otherwise. So it would certainly match the higher end solar modules on the market. What are they, 35 years now, something like that? So 35 years to me is easy to say, but could be longer. And in respect to am I seeing guys upgrade existing transformers? Nope, not really. Typically, no. Typically, where we can save money, we do. So, should you? Yeah, absolutely you should. If you're going to spend all that money, you should. But again, that's, you could maybe put one more module on the roof too for $300. So I don't know what's better. I think there's a threshold in it, and a good designer will have a better answer to that question than me. But would I do it? Yep. Probably biased though, so take that with a grain of salt.
What's your lead time looking like on orders? We have various suppliers out 50 weeks.
Wow. I hate to be that sales guy. Yeah, no, not that bad. We are prolonged right now and we're having troubles, guys. No question about it. We're fighting through nasty material costs. We get steel and copper and aluminum delivered daily to our plant. So it's a really tricky one for us to manage. Of course, we're buying on commodities and not selling on commodity, so it does make our lives pretty tricky sometimes. So I say that with a bit of a, just so you understand the position out there. I agree with the comment. It's bad, but really bad. Now, we're not that bad. So there, I will say that good news there. So 6 to 8 weeks probably right now would make me feel pretty confident. No expediting. So that's what I can say. Normally we can push something through, but right now we've been told not to expedite pretty much anything. Everybody's pretty testy out there from a manufacturing standpoint, right down to the owner level. And I have to say that across all of the lines we represent, it's been really tough, and those lead times you're discussing do exist. Right now we don't have any problems, but I'm pretty convinced that the minute I say that, there'll be a sinkhole on all the highways to Alberta and to the west. So if it depends on which side of that sinkhole you're on. I'm kidding, of course, but then you see what happened in BC here recently, and I say to customers all day, the dog ate my homework, and I don't even know what I'm going to say tomorrow to guys. But yeah, you're right to be focused on lead times. So what I would do in these situations is come in, get your POs in early as you can, put the order on hold, get it in the system. That's going to help you secure a meaningful lead time. I mean, anything you hear from me right now is meaningless, because the minute we get an order, the story changes. So right now, 6 to 8 weeks, but be very cognizant of all your lead times, as you know, and place orders often and talk often. That's what I would advise you. Talk all the time. Talk to your sales reps, get them, make it their problem. You know, like, I mean, I'm serious, because they're the only ones that are going to be able to advise you in real time if you talk to them, and the guys at BayWa are very good at that. So.
Great, I think that's it. Somebody else is asking about the presentation, but as I mentioned previously, this will be shared with all customers. So thank you very much, Ben and Amy. Really appreciate you taking the time to teach us more about FLO and Delta. Just for everyone else's sake, if you do have follow-up questions, please reach out to your outside sales reps. They're definitely there to help you. We do have some of the level 2 chargers in stock. Transformers are custom orders, but we have a great intake form, so just ask your rep for one of those. Our web shop has been down, as some of you will know, but some of these products will start to rear their head as we back on there. That will be coming up very shortly in the next week. And just thank everyone for taking the time to be with us, and hope everyone's staying safe out there.
Thanks, everyone.
Thanks, everyone.